So today we're going to look at modeling something like this using MASH. This is nothing difficult and it's been covered elsewhere. The reason I'm going over this again is because I think they've simplified the method for changing the color or randomizing the color. It seems like they've cut out one step. So I just wanted to document it step by step again. Also to look at this option of, let's see if I can find a good example here where it's kind of catching the light. Maybe this pink one here, where it looks like this object has beveled edges, so the corners look rounded. I just have a sky dome light in here, so it's not quite showing off that well. But if we actually look at the geometry, these are not beveled. So this bevel, or this apparent bevel, is happening only in the shader using the aiRoundCorners node. And this is a pretty handy node to use in some cases. It's not perfect, but it saves a lot of extra polygon faces and render time, and it also solves a problem with having to scale these up using the MASH random node. So we'll go through and we'll build this step by step. So let's just go into MASH, and I'll delete my MASH network here and just build it from scratch. Okay, so we still have a couple of lights in here, and I do have a polycylinder, so let me just show you. So that's what I started this from, just a 6-sided polygon cylinder with no beveling, and I moved the pivot point down to the bottom. If I look at the channel box, everything is zeroed out. So we are going to make our MASH network first. Very simply, we're going to create a mesh geometry type. And the reason we're doing this is because we need it to be a repro mesh in order to add the color variation node. We could start with an instancer and then switch it to a mesh later on. But this is not too taxing on the system, so I'll just leave it at mesh here. And we're going to start with a grid. We could do it with linear, but I'll just show you why I use a grid here. So apply and close, so it creates our grid right in the middle of the world, and it hides our original polycylinder. So if we take a look at this now, the MASH node, the distribute, so we don't need any in Y. So how are we going to set this up? Okay, I'm going to show you this way just to demonstrate something. So we only really need just one row here, like this. And so we're doing this in Z. And we can spread these out to start to make our first row of our thing here. But you'll notice that I've got it going corner to corner. So we're not going to get a tight fit because of these triangles that are made here. Now, how can I solve this? Well, I could solve it in the easiest way, is that I can actually do this in X rather than Z, where I know they're aligned in this direction. But if for some reason you wanted to keep it in Z, just remember that you can go back to your original polygon object and rotate it around. So I'm moving the polygon cylinder, the original one that this was made from. And if I modify its position, you can see that the MASH will update. So I'd probably want to go 30 degrees, and then I could freeze the transformations on the polygon cylinder. So this is one way to do it. It really will work either way you approach this solution here. So anyway, I want to get these pretty snug. Let's look at this in the top view. So these are pretty tight. Just going to hide my lights. So that's good. So now I could, theoretically make my grid this way by adding iterations in the other dimension, X in this case. But you can see nothing's going to fit snugly together. We need an offset here so they will nest together. So we are going to do that using a different mesh node called the replicator. So we'll add a replicator node. And here we can set the number of replicants. So this looks a little weird, but the default thing is to add an offset position in Z to -2. So for me, that doesn't make sense. I want to do it in X because of the way I have it set up. And now if I add replicants, now I can sort of do the same thing we were doing in the grid. But if I want these to nest together, then I can use the offset position Z just to offset them so they fit nicely together, and just adjust this. Right, so then we get nice fitting hexagons. But you can see it's fitting on a bias, which makes sense because we're offsetting it a little bit in X and then a little bit in Z, and that keeps adding up, right? So that's why we get this bias here. So another way to do this, and I will just turn my replicants down to 1 for now. So another way to do this, instead of using the offset position Z here, we can go down to this pattern setting. And so this will repeat a pattern every n number of replicants, and here I've got it set to 2. So now if I set the Z offset to something like that, that looks good. Now it's going to take the pattern that we've defined in these 2, and then when we add replicants up here, it won't keep adding to the offset. It will just reset it after each pair. So if we set this to 3, we would get something different. So this is a good way to do something like this. So now we want to make them randomized in their scale. So we'll go back to mesh and add a random node. And by default, I don't know why it's not popping over to my random nodes, my new nodes. By default, the random node is random in X, Y, and Z. So I'll just put those to 0, and then we just want to scale it up in Y. That's the reason I put the pivot point at the bottom, so it scales only in one direction. So that's pretty good. Now in my image here, we've got this sort of blank spot where it's flat in the middle, and that's where fall-off objects come into play. So if we right-click here in the random node, fall-off object, right-click, create, and it creates this new node that is this kind of sphere-looking thing that has an inner sphere and an outer sphere, and the effect of the fall-off node happens between these two spheres. So right now, we're only getting the scale effect in these areas here. So in the little sphere in the middle, that's where you get 100% of the effect, then it falls off out to the edge here. So if I double-click on the fall-off node here, then we can open up its node, which we'll see in our outliner, and we can invert the fall off, and that way this can be sort of a blank space where that scale effect, that random scale effect doesn't happen. And you can change the scale, size, position of this node, so you can do something like this. Okay, so we're most of the way there. Now we just have to randomize the color. I'm going to save this scene. So if we go back to mesh, to the waiter, we can add an add color node, right? So it just adds whatever this color is here. So I can turn this to red, and you can see that it's just filling the whole thing with that color. And if I were to render now, though, you can see it still renders with whatever material is on the surface. So by default, this just has a Lambert on the surface. So this color that is on your model, the repro mesh that comes through the mesh, shows up on screen, but it won't show up in the renders until you go through a couple of steps here. So one thing to notice here, that in the color node in mesh, there's a thing called color set name, and this is important. it's got to be set to this color set with capital S, and we'll use that name in one other location. So one thing we have to do is select the geometry. So this is the repro mesh shape, and go under Arnold and just turn on this thing down here under Arnold, export vertex colors. Still won't change anything. As you're doing this though, if you're not seeing something change on screen, you can just make sure you update full scene just so it refreshes everything. It's going to pause this for now. So what we need to do now is sort of build a conduit from between the mesh color node into the shader that we have on this object. So I'm just going to select a repro mesh. I'm going to add a new Arnold AI standard surface. Now we don't see the effects anymore. And if we render, we just see what we would expect to see for an unchanged AI standard surface. And let's take a look in the hypershade here, and I'll name this I'll map this out. Make this a little bit bigger so we can see what's going on. So we just have to connect something to the base color here in the shader node that can grab that information about the color that the mesh color node is telling us. And so what we use for this is an AI user data color. And we can put a value in here, or we can tell it to read an attribute. And so we can just type color set here. That's a unique name linked to this because of how it was described in the mesh color node. So we're going to connect the out color of the AI user data color node into the base color of my shader. And you saw immediately that I had my render still running, which is probably not the best idea in the world, but it's now grabbing that red color that was in the mesh color node. Let me just show that here. So if I change this to this green color, so this is now being fed from the mesh color node into this AI user data color, which is then going into our shader node. And if we go back into that color node, you can see here we can randomize the hue based on whatever this color, starting color is. We can also randomize the saturation, randomize the value, and so on. The good thing about this is, so this is in the mesh network. Outside of the mesh network, here in our hypershade, if we wanted to, we could add another node in between the user data color and the shader node. So if I do a color correct, color correct. So AI color correct, and we could take the out color from the user data to the input here, the output here to the base color. Just start my render again. So it's just passing through right now with no change. But in this AI color correct, here we could also do a hue shift. You could just up the saturation here. So I don't know if there's a benefit to doing it one way or the other. There are some more controls in here. But anyway, so you could do any sort of things. You could put, I suppose, a reverse node in here if you wanted to do that. So I could take the out color here into a reverse node, and now it's reversing those colors. So you don't have to do that. In fact, this will be confusing, I think, if I leave that in here. So I'm just going to go back to my original connection, where it's just taking those colors from the AI, or pardon me, from the mesh color node, transferring them over here. Okay, so finally the rounded corners. How do we do that? Well, that's easy. You just search for AI round corners, and then this plugs into your shading network, just like a bump map, except you don't need the in-between bump 2D node. You just take the out value from aiRoundCorners and go into normal camera of your shader. And let's see if this is working. I'm going to turn on my area light. Let's turn this up so we can see. I'm looking for the edge here that's catching the light. So these two purple pillars are doing a pretty good job of that. So let's just grab these so we can see what's going on. So if we go into the aiRoundCorners, there's samples, there's radius, and there are these things here. Inclusive refers to a trace set, so you can tag certain objects that you don't want to get this effect. Or you can do self only. So if you have two separate objects that are overlapping, it will try and show a rounded corner between those intersecting faces. So if you only wanted to round the one object, not the intersecting ones, you can turn on self only. But what you'll mostly be changing here is the radius and the samples. So you can't go too high on this without it all falling apart. So if I go to 0.5, for example, you can see it just looks wrong because, it's the corner here still exists. It's not making that transparent or anything. So it's just a bit of a trick with the normals, just like any bump map is. So for something like this, you probably want to go pretty light. And then to just make it look cleaner, you can turn up the samples. And this is the amount of ray tracing it does to figure out those corners based on the perturbed normals that are there. So if I just go in a little closer, you can see it's actually doing these corners too. So it doesn't bear close scrutiny, really. It kind of looks pretty bad if you're up too close. Well, I shouldn't say it looks bad, but it's less convincing. But if you're looking at your scene from a little bit farther away and you just want those corners to catch the light, then this is a pretty good solution. Let's go back to 0.1. So even there at 0.1, it's working pretty well. Let's turn off my backlight just for a second. Yeah, so you can see it's pretty good. It looks rounded. It's convincing enough, but it makes for a much lighter scene, right? And it allows that scaling to work properly. So if we scaled our actual geometry with a bevel on it, the bevel itself would scale, and it would start to look strange. This is applied after the fact, so we get nice clean corners that way, even if not perfect. Anyway, so that's how you adjust the colors to vary them in a mesh node, add the rounded corners, and use the replicator to make something like this.